hydraulic nut to tighten the spool in place, sorry, spindle in place, and then we have a sensor here, proximity sensor here, to sense the position of the exhaust valve spindle, and then we have lube oil in and lube oil out. So we have a control oil damper here for the exhaust valve air inlet here. So we have a closing mechanism for the exhaust valve, and also the sealing oil control unit. The idea behind this is that we have a flow of oil down to the lower part of the exhaust valve. So we have a lubrication of the ring pack down here, the sealing rings around the spindle of the exhaust valve. So therefore we're ensuring that we are keeping the oil system separate from the exhaust system. You don't want any exhaust gases passing through, contaminating our contaminating our oil system here. On all high force valves, exhaust valves, this was applied. However, complex design and also the problems were the actual movement and possible clogging. So we can see that inside here we have the sealing oil control unit, the pin, piston, and the spring. The movement of that. So we have pressure coming into the housing, forcing the piston against spring tension in this direction. Therefore, we have the pin coming out, which we recognize on board. Then we're charging this pocket of oil here. And then after pressure from the push rod has been released, then the spring tension will overcome. The piston will force out, and then the same here. The piston will force this oil down into the housing of the exhaust valve to lubricate. Here we can see the sealing oil control unit. Here we can see the feedback sensor for the position of our spindle. We have the damper inlet for the oil damper, and we have the drain pipes to and from the exhaust valve itself. The design of the high force valve was then replaced with the low force exhaust valve, and this is the common one in. Here we have the cost and power reduction. So the smaller design, less force needed to open along the side with the two-step actuator, with a reduction in the piston size. Therefore, we are also removing the cavitation inside the push rod. Therefore, a more smoother operation. Using the Duraspindle design, the Inconel coating on the top and bottom part of our spindle, and then we use a COL, controlled oil level, instead of the sealing oil control unit. And therefore we then extend the time between overhauls, also then reducing the cost of spares in the long run. Difference between the first and second generation. So we can see here on the left hand side we have the first generation with the pressure transducer and the rod lift rotation check. This stick here is to assist the crew to identify the movement and rotation of the exhaust valve. However, we know the rotation of the exhaust valve is correct when we do our maintenance at the correct schedules. I think it's 6,000 hours, 8,000 hours, then it's consecutive after 12 or 16, I can't remember, depending on the size. Then you do a full overhaul, and then you would check the mating surface of both the bottom seat and the spindle. Then also we need to know if the exhaust valve is open and closing. We don't need a stick to tell us that. We will be monitoring closely our exhaust gas temperatures and the performance of the engine. That is how, and the only real way we can find out how the operation is. This stick can move up and down, doesn't mean the exhaust valve is operating correctly, but never mind. Therefore, on the new design, we do not have the stick. We have a inductive sensor for the correct position, the correct movement of our spindle, so we can see the position of our exhaust valve from there. Here we can see that we have the difference between the first and second generation of our oil and air cylinder. We've reduced the oil and air cylinder, so therefore we have a smaller design, and therefore we are also simplifying the air spring by removing the reducing station and giving us the maximum of 7 bar for the closing of our exhaust valve. Doing this also, we have removed the tightening cone by placing the cone form, the conical form for the feedback sensor for more direct reading onto the spindle itself. The air cylinder, we can see it's a bit squashed, the picture, gentlemen, apologies there. The air cylinder itself, we can see that we have the air coming in, and we have this piston which will then compress as the exhaust valve opens, compress here. Then we have the safety valve. The safety valve is very important. Safety valve should operate with every operation or opening of the exhaust valve, no matter what. We need to control inside here this pressure, and therefore we are then at the same time controlling this COL, controlled oil level. So we have a oil bath for the lubrication, the constant lubrication of our sealing rings around the exhaust valve spindle. So we can see here that we have the safety valve, which operates every time we have a opening of the exhaust valve, because the pressure in here should increase. And then we are maintaining, even though it's called a safety valve, we are maintaining the pressure at the correct setting. The pressure here for the safety valve is stated in your manual on board for your maintenance, and it will be between 21 and 23, and sometimes 25 and sometimes 19. It is specific to the exhaust valves on your engine. I think they're normally around about 21, 23. It does change. Just make sure that you are setting it correctly. So you would have to remove it when you are doing any overhaul. You will put it into the gauge block that is on your tool panel, and then you would attach the hand pump, and then you would jack up and check the pressure and adjust accordingly. Okay. The Dura spindle themselves, not so new anymore. This has been in service for many years, a decade at least, if not 2. And we can see that we have, on the top part, we have put on this Inconel coating with the 718 code, and then on the bottom part we have put an Inconel coating with a 625 code. This is so we have a hardening surface for the main. This is the one, this part here is the one that's going to be hitting or closing against the bottom piece of the exhaust valve, and then we also put a hardened coat on the bottom to remove the possibility of burn off. So we can see a comparison between the mnemonic spindle and the Dura spindle. Mnemonic is still in service. If your vessel is running with mnemonic, then you are to run with mnemonic. If you are thinking about changing to Dura spindle, then you need to get a hold of MAN to find out if it is possible. If it isn't possible, then you need system. Then your engine needs to be fitted with a mnemonic spindle. But you can see, looking at here, that we have the grooves here. This is the mating surface between the bottom piece and the exhaust valve spindle. Whereas we're looking at the Dura spindle with the W seat, there is only a light cleaning. You do not need to grind the Dura spindle anymore. It is light cleaning, whereas the mnemonic spindle you can still grind here. So talking about the bottom seat with the comparison, also with the look at the journey through the design.